You are welcome to tutorial 5, where we are going to deal with position, distance, and displacement. Position, distance, and displacement. Let's start with position. What is position? Position is the location of a point using rectangular coordinates. The location of a point using rectangular coordinate is position. For example, if we have two lines crossing each other, the values you have on the x-axis, the general x-axis, you call it abscissa. Then the value you have on the y-axis, you call them ordinates. Now, if we have a point here which represents position, we can locate this position by tracing this dot line from the x-axis to the point where you have the position, and then from the y-axis, that is general name, where you have it, if this is A. So you can see that we use rectangular coordinate to locate that position. So position is the location of a point using rectangular coordinate. Good. Now this position we'll see for general case if here is x-axis and here is y-axis. The x-axis and the y-axis representing the abscissa and ordinate can be given in bracket form as thus. You have x, y. This is for general case. You may be given value in figure form 2, 5. So if you are given anything like this, you are asked to translate as seen on this sketch here. Instead of writing x, I'll write 2. Instead of writing y, I'll write 5. So the first value you have represents the x value, which is referred to as abscissa. I'd like us to get that. Now, that is for position. Let's quickly look at distance. What is distance? In physics, distance is the length covered by a moving object. If you measure the length covered by a moving object, what you have, we call it distance. For example, if we have 2 points, say point A and point B, and if an object wants to move from point A to B, and the object follow this path, they now ask you, what is the distance covered by this object? Remember, the total length moved by the object or covered by the object, we say it's distance. It is simple to use thread, long thread, follow this path, and at the end use meter rule to do your measurement. The result you have, you call it distance. Now, we'll have the last term there, which is displacement. But I'd like us to get this, because when we say distance, we just stop here. Later, you may hear us give another definition which is acceptable. What is that definition? Distance is the product of the average velocity and time. You may hear that later. Average velocity and time is still acceptable, but to a layman, the length covered by a moving object. Okay, let's go to the displacement now. Now, displacement is different from distance. People confuse displacement and distance, but they are different things entirely. That is why later, in our other tutorials where we'll talk about vector quantities and scalar quantities, we'll stress this very well to differentiate distance and displacement, where distance fall under scalar, and displacement fall under vector. Displacement a vector quantity. Distance is scalar quantity. We'll deal with that later. Let's just finish this. Now, for our definition here, we say displacement is the distance traveled in a specified direction. That is the number one definition I'd like you to get. The distance traveled in a specified direction. Now, if you are doing any calculation concerning displacement, you alongside calculate the direction, the angle involved, or else you lose some of your marks. Now, in this diagram that we'll have on the board, considering this diagram, if they ask you what is the displacement, you can give another definition which I will demonstrate on the board now. Displacement is the shortest distance between 2 points. The shortest distance between 2 points, that is number 2. I'm giving us the second definition now. The shortest distance between 2 points. You may wish to add the number 3, it's also acceptable. Displacement is the distance between the end of a moving object and the beginning. The shortest distance between the end and the beginning of a moving object. For example, the shortest distance between the end and the beginning of a moving object, it is from this point down to this point. So if I measure, use my ruler, just measure it straight, what I have is displacement. Displacement. Why this one is distance. That is it. In order to throw more light into displacement and distance, let's solve this question we have on the board. The question we have here, let's solve this question. Okay, now the question reads, from the figure above, calculate the distance covered, B, displacement, C, difference between A and B, and our A is distance, B is displacement. So calculate the difference between distance and displacement. Now there must be difference because in general, distance value is always higher than displacement value. So they say we should find the difference. Now, in order for you to solve question very well, you should be able to interpret the question, understand what the question is saying. Like what we have here, an object moved from point A to point B, covering a particular distance. What is that distance that we are using here? We are using 8 kilometers here. Covering a distance from point A to B, 8 kilometers. The body still continues, move from point B to point C, covering 6 kilometers. Now we are asked, the first question there, what is the distance? Remember definition for distance, the length, the total length covered by the moving object. The first length is A to B, 8 kilometers. The second length plus 6 kilometers. So what is the distance? 14 kilometers. Let's write it down. Let's write it down. So our A distance is equals to 8 kilometers plus 6 kilometers, which gives 14 kilometers. We are done with that. B says we should calculate displacement. In order to calculate displacement here, from that definition, which we have, that displacement is the shortest distance between 2 points. Remember, the object moved from A to B, from B to C. The shortest distance here is from A to C. From A to C, so we are calculating line AC, which will give us our displacement. Looking at it also, you discover that we have triangle here. And to solve, we have two sides. We don't have one side. We can apply Pythagoras theorem to solve this problem. Pythagoras theorem. By Pythagoras, we have line AC squared is equals to 8 kilometers. Will come to the SI units later. 8 square plus 6 square, which is 64 plus 36. And at the end we'll have 100. 100. Now we'll have line AC square is equals to 100. I'm looking for AC, line AC, which is the displacement, not AC square. So I take the square root of both sides in order to counter this square here. So this square root counter this square, and I have line AC is equals to 10. I don't just leave my answer like this. If there is no SI unit, there is challenge. That is why in our tutorial 2, you see fundamental quantities and units. They are important. So what SI unit have I here? Kilometer. Now, if I leave my answer like this, I'll miss some of my marks. Why? I'm calculating displacement. I need to also calculate the direction, because we say displacement is the distance traveled in a specified direction. So we need to specify the direction here. To get the direction here is simple. We'll have direction 1 and direction 2. We can calculate with respect to any, provided we know how to represent our answer. Now, if we get direction 2, since we have angle 90 here altogether, we get direction 2, it's simple to get direction 1, but there is no need. Since we get 1, we are okay. They will mark just 1. Now, let's see the direction in this case. If we want to calculate the direction, which is direction angle 2 here, we use trigonometric ratio. Trigonometric ratio, where the angle is facing is the opposite. Here is the adjacent. So we'll have opposite over adjacent giving us tan. Tan theta becomes equals to, the opposite is 6 kilometer all over, the hypotenuse is 8 kilometer. That's what we'll have. But kilometer will go with kilometer. And in this case, we are dealing with theta 2. So theta 2 comes equals to tan inverse of 6 over 8. And tan inverse of 6 over 8, what have we? We'll have 36.87. We'll have it to be 36.87. That is what we have. But we need to put the angle, the direction rather, north of east. Now, check it. You have 36.87 north of east. If you have this, you are okay. If you want to calculate based on angle 1, you can still do that. Angle 1 plus angle 2 is equals to 90. Make angle 1 subject, so you are subtracting 36.87 from 90. The result you have will be 53.13. Or you have 53.13. But in this case, you put north, then east at this point. You can give any of the angle, it's acceptable. Then, finally, we're asked to calculate the difference between the distance and the displacement. When we say difference, they're talking about subtraction there. Subtraction, difference. So, the third part, which is C, difference will be equals to, like I said earlier, generally the distance value is always higher. So distance value, which is 14 kilometer minus the displacement value is 10 kilometer. And finally, what do you have? 4 kilometer. We have 4 kilometer as our answer. 4 kilometer is the final answer. 4 kilometer is the difference between the displacement and the distance. Now, I don't know your understanding level with this question. If there are some things you still need to get, why not? You can just replay to get proper understanding before you forge ahead to the next tutorial, because we are going to tutorial 6 very soon. We are going to physics tutorial 6 very soon. Let me test you with this question and we'll see the answer you profile. That is your assignment. Let's use your physics tutor in this assignment we want to give you. If Mr. Onuche Jerome Zakari moves eastward, covering 700 kilometers, when he covers 700 kilometers, he discovered that something fell off and he has to go back to pick that thing. And if he moves 5 kilometers backward to get what fell off, move 500 kilometers backward to pick what fell off. Here is east, here is north, here is south, and here is west. Now, the question here is, what is his total distance covered when he got to the point where he is to pick this thing that fell off? What is his total distance covered? What is your answer? Check it, check it. What is your answer? Total distance covered. Okay, the expected answer is 1,200 kilometers. Now, that is for the distance covered. What is Mr. Zakari's displacement when he got to the point that he was to pick this thing that fell off? What was his displacement when he got there? What's the displacement? Now, the displacement is simple. I should give you the expected answer. Now, let me do my working and give you the answer. The displacement will be 200 kilometers east. 200 kilometers east. That will be his displacement. 200 kilometers east. The east there give you the direction. Now, finally, what is the difference between the distance covered and the displacement? Remember, the total distance is what? 1,200. And the displacement is 200. So, 1,200 minus 200. You have 1,000 kilometers. Thank you very much as we move straight to Physics Tutorial 6.